there's an Fy going up, an Fn going up, and an Fg going down. So we cannot say Fn is equal to Fg. We cannot say that. Okay, because there's another Y force playing in. So we can say Fn plus Fy is equal to Fg. Okay, then my question to you, Fatima, is these forces, do I highlight them blue or yellow? Okay, my question to you now is, if this X block goes down, in which direction is this block moving? To the left. So this one's X components is linked to this one's Y components. Ne? Fatima, hierso? Yes, yes, yes. So we must highlight it yellow. Oh. I want you to quickly write it down. Okay, because it's a lot of money left and then I can start sorting it out. So you can sit in my class now. I'll give you a in the paper. You need someone to help you to write it. Do you know what you want to say? Is it just you or is it other people as well? Okay, just if there's people that confirm whatever it is, just write an answer at the bottom. So if you want to speak to someone, I know. Yes. Because if yes. Okay. Do you agree? This thing is now linked to this thing. If this thing goes that way, in which direction is this equator? Up. And if this thing goes to your right, which way is this thing going? So the same thing here is if this thing is going to the left, this thing is going to go down. So this one's up and down is linked to this one's left and right. So this one's up and down is linked to this one's left and right. Or another way that we can look at it, if I highlight tension yellow here, then tension must be yellow there because it's the same road. Same road.
How do we know it's going down?
They say there that the 5 kilogram block is accelerating to the left. And then this one's going there. Okay, so that's the last thing I want to do here is what Fatima just said. So you must choose positive directions. Okay, this thing is going to the left, so I choose to the left to be positive for the 5 kilogram. And then I'm going to choose for this one down to be positive, not up. Okay, because if this one is moving to the left, then this one is going to go down. That must make sense. You can't choose up to be positive. Okay. Then they asked us question 3.2. You must draw a three-body diagram showing all the forces acting on the 5 kilogram block. But now we just did that. Now, I did tell you this at the beginning of the year, but I think you forgot. End of grade 12, they want you guys to draw this. They want you to split it up into components and they want you to highlight it, but not as your answer to a question, as part of your planning. Okay, so our question now is draw the three-body diagram. So now you're going to quickly redraw that diagram without splitting up the forces, without highlighting. Okay, so this is Fk, this is Fa, N, T, and Fg. Okay, then 3.3.1, they say calculate the magnitude of the normal force acting on the block. 3 marks. Now, if it was just as easy as, oh, normal force is equal to Fg, that would not have been a question at all. So the fact that they ask you that must give you a clue. Wait a minute, there's something fishy going on with normal force. Where is normal force? There is normal force. I highlighted it blue. So I must look at all the blue forces together. Okay? This block or this thing here is not going up or down. It's moving actually to the left. So it means it's up and down is in equilibrium. It's up and down is at rest. Okay? So what I'm going to do is I'm going to say all the forces up, the Fn plus the Fy, must be equal to the Fg. So the forces up must be equal to the forces down. Okay? So that means Fn is Fg minus Fy. How do we calculate Fg? It's 5 times 9.8 and Fy, ek hoor julle. Okay, I'm just drawing my triangle again for the people that haven't done this in a while. So there's my Fy, angle 50. So it is opposite over hypotenuse, which is sin. So it's going to be 50 sin of 25. Someone knew what to do? And the unit? Meters. Now they ask for the magnitude, the size, so you do not have to give direction. Okay, 3.3.2. Calculate the mass X of the hanging block, 6 marks. Okay, mass X of the hanging block. So what they're basically saying is, look at the hanging block. Hanging block, there's the hanging block. Okay. Okay, so I'm going to look at X. Now, just because I know something's coming, I'm going to do it on the right hand side. Okay, I'm going to look at X. F net equals M times A. Why do I say that? Because this thing is accelerating to the left, and because it is attached to X, X will be accelerating down. Okay, so that's why I'm looking at that formula, and I choose down to be positive. Then I have Fg minus T equals M times A. Fg is going to be easy because it's X times 9.8. T, do I have T? No. Do I have X? No. Of mass? No. I have the acceleration as 3. Okay, so problem. Okay, the question is calculate X, but I don't have tension. Where will I find that tension? Does what? There at the 5. Okay, so if I get that tension, I can get that tension. So now I say, okay, wait. Before I can look at X, I must first look at the 5 kilogram block. Again, F net equals M times A because it's accelerating, and I choose to the left to be positive because it's accelerating to the left. There I have T minus Fk minus Fx is equal to M times A. Okay, so I'm going to show in the picture. So it is T minus Fk minus Fx. So I'm looking at all the yellow forces. Okay, so I want to figure out what is T, so I leave it there. How do I calculate the frictional force again? Okay, so you will see I love to use my sideline thing, info table part here. Okay, please do that. So do not write next to one another like this. Never, ever, 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 ever in the exam. Okay, use that line to figure out your nonsense that you want to figure out. Okay, so how do I calculate the UK? Fk again? UK times Fn. Do I have the coefficient? Yes, they told me that is 0.2. Do I have Fn? Yes. I just calculated it. Now remember, from one question to the next, we work with your mistake. Make vote. So if you got the wrong answer there and you substitute in the correct place, you can still get full marks for the next question. Okay, minus Fx, let's see, there's Fx. So it is adjacent over hypotenuse, so it's the cos. So it is 50 cos of 25. The mass is 5 and the acceleration is 3. Okay, so we get the tension to be, and I want everyone to type that in. Everyone practice, see that you can do it. Everyone's got a calculator for the exam, eh? Who's not everyone? What is your plan? Will you? please, it's important. Where is your calculator? Gone, missing, stolen. And your cell phone, is that stolen? Mm. This is as important as a cell phone. More important. Because your future is in here. For maths, science, accounting. Life sciences? So you don't take life sciences? Well, okay, done with my preaching. You got 65.889. Yes? So you put that in, 65.889. You did not get that. What?
And the decimal places I got 884.
You probably did not round off there. But it's not the end of the world. 884, 889, it's fine. Okay, then let's check here. So here I have 9.8x minus 3x gives me 65.889. So that gives me 6.8x is equal to 65.889. And then you get that to be 9.6. I get 9. He will get 6.8, I think. And the unit for that? Kilograms. Okay, now please check here carefully what you get marks for. You get marks for formula. Then you get marks for substituting. Now, with your substituting, especially here where you have lots of substituting, if you have plus 50 blah blah blah, it's wrong. Then you choose to the right to be positive and up to be positive. Yes, no. And then this A must then be minus 3. Okay, so please check for that. So you get 6 marks. Let me just check. 1, 2, 3, 4, 5, 6 marks. 1, 2, 3. No, wait. Not there. Yeah. Okay, now they ask you 3.4. How will the frictional force on the 5 kilogram block be affected if the angle of the 15 Newton force is increased to 30 degrees to the horizontal? Right? Only increase, decrease, or remains the same, and then explain your answer for 3 marks. Okay. Young man, quickly take your bag off. Thank you. Alright. So, can I move away from this? Yes? No? You're all finished writing? Okay, so our whole scenario now changes. We originally had this block there, 25, and now we have it there at 30. X, Y, X, Y. Okay. And then they ask, but what will happen to the frictional force? Done. And wherever you want. Okay. So, man, it's like frictional force has nothing to do with F and with Y, so it remains the same? No. Okay, why not? Because Fk is linked to the coefficient and the normal force. Now, my first question is, did the coefficient change? No. When will the coefficient change? There's one scenario where it will change. Only one. Not when an angle is increased or decreased. Not when a force is increased or decreased. Not when the surface changes. When we don't have a table anymore, but now we have a cloth. We don't have a block, now we have a cube of ice. Okay, so the type of material change, then the coefficient changes. So we're not there. Okay, so then did the normal force change? Let's see. Normal force we had there's gravitational force, normal, gravitational, gravitational, normal, normal, gravitational. Is the normal force linked to Y? Yes, because they are both in the vertical plane, and if this one changes, if it becomes more, then Fn becomes less. Okay, so what happened when we increase the angle? Let's check. Okay, now you don't have to do all of this as an explanation. I'm just giving you a very thorough explanation. Let's just check. If y is 50, what was it, sin of 25. Who's on a calculator? Quickly calculate that, please. And if y is 50 sin of 30, or if where are you busy? Yes. Wag, sê gou weer. 21,13. Yes, or oh, on the dot, yes. Okay, so can you see that the Fy increased? It went up. When the angle got bigger, this y component got bigger. Okay, now remember, for this one, Fn was Fg minus Fy. For this one, also Fn is Fg minus Fy. So if the y component got bigger, if g remains the same, then what happened to the normal component? It decreased. Okay, so from here to here, we can say if y increased, and then we can say, okay, so from here to there, the Fn decreased. So if we look at this formula again, if the normal force decreased, what will happen to the frictional force? Increase or decrease? Decrease. So our answer thus is it will decrease. Now we must give reasons, because this here is just our nonsense for ourselves. It counts 3 marks. So this here is 1 mark, and then I must give 2 other facts, 2 other statements. Right. Okay. So decrease, our first thing that we saw is when the angle increased, what happened? If y increased, that caused Fn to decrease. So that's our first statement. Is we saw that when the angle increased, then Fy increased, and thus Fn decreased. Okay, now please in the test on exam, do not use arrows. Ne? You write out increase, decrease, blah, 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 blah. Okay, then from there, we looked at a crucial formula. Yes, we looked at formulas there, but that's not formulas on your data sheet. This formula is on your data sheet, so you refer to that formula. So then we say, okay, in this formula, according to this formula, if Fn decreased, then the frictional force will decrease. Thus, Fk will decrease. Yes.
You said that frictional force is higher.
Yes. From that formula, you can either say that or you can say this. Okay. Okay, now I know you're like, yo, ma'am, all this work for 3 marks. Remember, 3 marks is how many seconds? How many minutes? 3 minutes? 180 seconds. 1, 2, 3, 4. It's a lot of time. Okay, so please attempt it. Please. Okay. Right, then you had to do question 4 as well. Okay, it gives you there that block 60 A blah 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 B and 30 degrees. A 60 kilogram block is pushed along a rough horizontal surface AB with a constant force F. Now, a constant force F does not necessarily mean constant acceleration or constant velocity or something. It depends on the type of material, it depends on the weight, it depends on the angle, it depends on blah, 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 blah. Okay. Right. The box moves to the right at a constant velocity. That is your clue. That is capital letters. Bing, 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 bing. Constant velocity means Newton's first law, which means that there's no acceleration. F net is equal to 0. The coefficient of friction is 0.3. 4.1. State Newton's first law in words. Poitumelu. First law. Well done. Okay. Right, 4.2. Well, what we forgot to do is to draw a free body diagram of all the forces acting on the 60 kilogram block. 4 marks give us 4 forces. 1, 2, 3. How do I know there's friction? 2 words. They said, no, not 2 words, 1 word. They said coefficient of friction. Coefficient of friction tells me there's friction. Normally they'll say over a rough surface. Now, so my question to you is, there is a force acting there. How do I draw it? Do I draw it there or there? Option 1 or option 2? I'm going to show you my options again. Option 1 or option 2? Option 2. You are never ever allowed to draw your arrow that it points to the bullet. It must always point away from that black dot. Okay, so there we have the FA. Okay, again, you are special, you're in my class, you are clever, you are meant to be here, you have a purpose. Do you guys believe that? You are born for such a time as now. Yes? Okay. Right, so you're not going to leave it there. You are going to split it up into its perpendicular components, the y and the x component. You're not going to leave it there. You're going to highlight the forces you're allowed to add and subtract from one another. And immediately when you do that, you see, okay, wait a minute, I can't just say Fn is equal to Fg. They are not the only 2 blue forces. There's another blue force there. So Fg plus Fy is equal to Fn. Okay. Right, then question 4.3.1. They ask for 6 marks. Calculate the magnitude, the size of the following of F. Of F. Okay, so this is a difficult one, ma'am. There's F. F is at a weird angle. I didn't highlight it any color. So now I have to choose. Am I going to look at the yellow or am I going to look at the blue? Which one do you choose, Rafilu? The blue. Okay, let's check. Can I calculate Fg? Yes, because I have the mass and I have 9.8. Can I calculate Fn? You can't. Because you need Fy, that is the question, to calculate Fn. So you can't. So that's why we have to look at the yellow forces. Okay? Now, I did say this at the beginning of the year. Again, I'm going to repeat myself. You start with this formula that is on your data sheet. F net equals to m times A. But then afterwards, you fill in F net is equal to 0. Why? Because the acceleration is equal to 0 because it's moving at a constant velocity. But they want to see that formula there. Okay, because that's the formula that's on your data sheet. Okay, I'm looking specifically at the yellow forces. It's moving to the right, so I'm going to choose to the right to be positive. So I just quickly want to check. I saw that they said we're going to have register class because you need to receive a letter saying the school comes out earlier and on Friday, and there was something else. Okay, there's going to be a register period in 2 minutes. Okay, while that is happening, whatever, I'm not here tomorrow in your class. I'm going for a checkup for the baby that is showing. Thank you, Fatima, to say that I am getting nice and round. I want to buy this orange dress. But I'm so scared I look like an orange, like a Nazi. You know, so another thing. Okay. Yes. And remember my first two babies, I didn't find out. I will see how I feel when I go. Anyway, let's not chat about that. So on the same page that we're busy with now, it goes to question 5 there at the bottom. So tomorrow in class, so you don't have any homework. Tomorrow in class, question 5, it goes on the next page, question 5 there. And then I also want you to go to page on 2 pages. I don't have my page. Go to page 15, and at page 15 at the bottom, I want you to do question 9 and question 10. Question 9 and 10 in class. I told the principal that it's fine if you stay in my class and don't go to Phsc because you will behave. Yes? Yes? And you will do the work. Yes. You will report back to me. Right. Thank you, grade 11s and 8s. Good afternoon.